Hello, let's go today from that question 680 valid palindrome 2 is asked at meta. So here we need to validate if the input string is a palindrome, but it's okay if we can delete at most one character from it. So for example, in this case we can delete C, and that would be still considered as a valid palindrome for that problem. So now how can we do it? It's actually gonna be quite simple. So we will be using regular technique for detecting if something is a palindrome. The technique is something called two pointers. So we would have left pointer pointing to the beginning and right pointer pointing to the end, and then we're checking if those are equal, and if they're equal we're moving forward. Okay, and then if they're equal, let's assume that those are that C is B. Let's assume format. So now those are equal, and if we move once more, we iterated over everything. So yeah, we can return true. But obviously, if in normal palindrome validation, if we have a situation like that where they not matching, we would return false. But now in this problem, we can remove one character. So now the problem is that we don't know which one to remove. Yeah, we can remove B, but what if there's something down the line matching that B, and the same with C. So we have those two options here. So now why not to check those two options, and that's essentially what we're gonna do. We're gonna essentially create sort of recursive function which just checks both versions. So probably it's actually easier to code it than to explain. So yeah, let's code it up. From time and space complexity, that will be still linear of n time, because in the worst case scenario we would need to consider two cases. So in the worst case scenario, we would iterate twice through the entire string. So it would be like 2n, which boils down to O of n. And when it comes to space, so we're gonna have that sort of like small recursion, but that's gonna be just two additional functions to consider, those two additional possibilities. So in this case we can say that the time is still, or space is still constant. We're not really gonna use any additional space. Okay, let's see how we can do it. So I'm essentially gonna create a new function called check if palindrome, let's call it. And I will need left pointer, right pointer, and now I will also need a third argument to see to check if I'm running that function first time, or if I deleted something and I can't delete anymore. So let's call that third argument has deleted, let's say, character, and now we can have our 2-pointer part where while left is smaller than right, we'll be moving left forward and right backwards. And now if they're not matching, so if S at L is not matching S at R, normally we would return false. But if we haven't deleted anything yet, then we're gonna consider those two cases. So we're gonna say, let's go and check what happens. Let's call it correctly. Let's check what if we delete left one, and let's see what happens if we delete right one. And now we cannot delete any longer, so we're gonna have that third argument as true. Okay, and now if we go successfully through that, will be returning true. And we need to run our function, check if palindrome. Gonna start at 0 and ending is at slength -1, and we haven't deleted anything because we just started. And that should pretty much work. Let's see. Okay, that works well. Yeah, and yeah, that worked. So sort of follow up to that question is that that we should scale it to take any argument as a deletion count. And there's actually a separate question, which is this one, which asks, to for us to delete at most k amount of characters. But yeah, that's sort of I guess topic for another video. With this code we can scale it pretty well. We could have just a counter instead of that boolean. That wouldn't be the most optimal solution, because we're gonna have 3 arguments. We're gonna have that 3D 3D memorization, 3D memorization rather. But yeah, we're gonna discuss that problem later on. Yeah, that's pretty much all. Yeah, when it comes to time and space complexities, yeah, we pretty much just iterate through those. We just need to, at one point, in the worst case, to check, 2 possible options. So in the worst case, we're gonna iterate, over each character twice. But yeah, still, we can assume that our time complexity is linear. Yeah, if we have to scale that to accept k amount of deletions, then our time complexity would be higher. But yeah, that's pretty much it. Relatively simple question, although definitely not trivial. It could be definitely considered as medium. Yeah, that's all for today, and thank you, and see you in the next videos.